Yes, class. Am I audible to all of you? Amna, Deborah, Fadil, Rajita, Sidra. Okay.
Yes, ma'am.
Okay, class. So, see, yesterday we had stopped at this point. We had to start with conversion of galvanometer into ammeter and voltmeter. This is a very easy topic, formula-based topic. No tricky question is going to come from this topic. Just formula-based, you have to understand how to write it. See, if you have a galvanometer, suppose a galvanometer is present. Now I just have the galvanometer and the work of the galvanometer is to detect the current, right? Detect it, not tell the exact value of current, right? So if I want to convert it into ammeter, I want to find out the value of current and I want to find out the values of resistances and all. So how will I do? There's a device, not a device, basically a resistor. A resistor we have, which we call it as the shunt. So shunt has two properties. It's just a name given to the resistor. It's a simple resistor. Even if you take the name of a resistor, it's fine. So we connect it in parallel, one point, and second point is that the resistance value is very small. These 2 points you have to remember. So connect it parallel to the galvanometer like this. This is the shunt. Connected parallel to the galvanometer. Second point is that its value should be of small. This term, no shunt here you are seeing. Shunt is very important to remember because this is a name specifically used in this lesson, in this portion, in conversion of galvanometer into ammeter. Nowhere else you will find this term. No synonymous term is present for this shunt. All right, so just remember it. So if the total current I is coming, so suppose Ig is the amount of current that flows through the galvanometer. G is the resistance of galvanometer. So Ig is flowing through it. Fine. Ig is flowing through it. If from Ig has gone, we are left with I minus Ig. So I minus Ig is passing through the shunt. This is the case. So yes, G is the resistance of galvanometer. S is the shunt resistance. Ig is the current flown through galvanometer. Okay, shunt connected in parallel, small resistance. See, potential difference across both these arms. Potential difference across this arm is equal to potential difference across this arm. Why? Because they are connected in parallel, right? So how do we write the potential difference? Use Ohm's law. V is equal to IR. What is the current? IG. What is the resistance? G. What is the current? I minus IG. What is the resistance? S. So how should I write it? This is Ig into G is equal to I minus Ig into S. So value of shunt resistance from this is Ig into G divided by I minus Ig. So this formula we'll be using. Simple formula you will get to calculate the value of shunt. That's it. This is how we convert galvanometer into ammeter. Write it down, then I'll discuss about voltmeter. Why do we connect it in parallel? Why not series? Shunt. You're asking why do we connect shunt parallel?
Yes, ma'am.
When we are connecting shunt parallel to the galvanometer, it keeps the resistance low. The value of resistance, it keeps it low. So which can be further used to measure the current strength in the circuit. All right.
Okay, okay.
Avoid over voltage and to keep the resistance low.
And ma'am, for G, we wrote resistance of the galvanometer. It's the internal resistance.
Hmm?
For G, why did we write resistance of the galvanometer, ma'am?
G is the galvanometer is also having its resistance, no?
Resistance. Okay, okay. Yes, ma'am.
That the way we represent it through R here by the device, it has
Right.
to denote.
Yes.
Okay.
Okay.
Done class. Now see, conversion of galvanometer into voltmeter. So just opposite to it. Whatever we have studied for ammeter, it's opposite to it. Galvanometer is there. We connect a resistor high series resistance. Means the value is high and it's connected in series. So simple resistance R, we'll write G is for galvanometers. Ig is the current that is flowing. Now see here, you don't have the concept of potential being same or like this because it's series. So we'll straight away apply Ohm's law. Now class, tell me one thing. Resistance of this device is R. Resistance of galvanometer is G. What should I write the equivalent resistance as? Equivalent resistance? What should be the equivalent resistance? By now, this should be very quick by all of you.
Ma'am, is it 1 by R plus 1 by G?
No, Fadil. That is the formula for parallel combination.
Acha, then R plus G itself.
Simply R plus G add karo.
R plus G, right, okay.
Okay. Parallel
Yes, ma'am.
combination for resistors and series combination for capacitors. Don't be confused because you are in
Yes, ma'am.
confusing stuff. So it's G plus R. So now you apply Ohm's law and current is already G. Now see IG. Here current is IG. So when we apply this Ohm's law, V is equal to IR. So potential will be current is IG, resistance is R plus G. Check. Now see, from here, if I write what is R plus G? R plus G is V divided by IG. So resistance value is V divided by IG minus G. One question also we will see that will clarify the formula part, and it will help you also guide how the questions come. Very easy questions are there from this topic. It's just that you have to remember which one, because students, what they do, I have seen them in their answer sheets, they mix it up. Ammeter ka voltmeter mein likh diya, voltmeter ka ammeter mein. Just be sure which one is. In ammeter, we connect low resistance in parallel, which is known as shunt. And that is only unique for that particular case in your entire physics till now, which you have to apply. And in voltmeter, we apply high series resistance. Note this down, one question we'll see. See, this question is very simple. This says that an ammeter of resistance 0.8 ohms can measure currents up to 1 ampere. What must be the shunt resistance to enable the ammeter to measure current up to 5 amperes? Second is combined. Okay, this we'll see later. First part, let us calculate. See, shunt is equal to Ig into G divided by I minus Ig. So what is Ig? Ig is
Ma'am, the current
to 1 ampere.
1 ampere is
1. Resistance of the galvanometer, an ammeter of resistance. So here our galvanometer has been converted into ammeter. So resistance, this is G given, 0.8 ohm. Because ammeter, galvanometer, no, it's actually your ammeter here. There is no device as such ammeter separately. We do not have ammeter. That's why we are performing these calculations. I. What must be the shunt resistance? S we have to find out. I enable ammeter to measure. Okay, so total current of the circuit is 5 amperes. This is 5 minus 1. 0.8 by 4 is equal to 0.2 ohms. Simple. See, second part says what is the combined resistance of ammeter and shunt. See, what is the resistance of ammeter? Resistance of ammeter or G, both are same, no? Resistance, so this is actually asking you resistance of galvanometer, which is 0.8 ohms resistance of ammeter. Shunt you have calculated it from the previous part. That is 0.2, not 1 ohm. Okay, you have added them. See, shunt is connected in parallel. How will you add them directly? Combined resistance of ammeter and shunt means their combined resistance, galvanometer and shunt, how they are connected? They are connected in parallel. So R equivalent would be 0.8. Directly, let me write it. This would be 0.8 into 0.2 divided by 0.8 plus 0.2. This becomes 0.16 by 1, which is 0.16 ohm. This is the answer. Write it down, then take a break of 2 minutes, then we'll start with chapter 5th. See class, don't worry about the syllabus. Now the lessons that are left in this batch which we are doing at 9 p.m. or 8:30 p.m. This is, see, chapter 5th will be started. This is small. EMI is a very small lesson. AC is also small. It's just that a little technicality is there in it to understand. So that we'll do. And EM waves is a lesson of only one class. So all these lessons are very small that we are dealing. The second book is already going simultaneously. That's why I'm not hurrying up so much. But I'm not taking more extra classes. Because you people are already attending extra classes in the evening, right? Before this one, which you are attending at 6:30 IST. So again, if I take your extra classes for the first book, then you all have to attend more classes, right? That's why I'm not taking. But ray optics is going smoothly there. Let us see how much we are able to complete by the time we are completed with ray optics. Ray optics will also be completed. Almost we'll reach towards the end next weekend, Saturday, Sunday. And EMI also will be, half of it will be done by the next weekend. Yes, class. So starting with chapter 5. This is magnetism and matter. So here we deal with the natural magnets or permanent magnets. Natural magnets, like you have the concept of earth magnetism. We'll be studying about earth magnet. We'll be studying this lesson into two parts. One is earth magnetism, and like permanent magnets, we have bar magnets. These are the two portions which you have to study. So earth magnetism, it's a very short topic. I'll deal it at the end. First, let us go into the details of bar magnet, because this is also very small, but some details you have to remember, because you never know which small details are asked to you in the exam. As I told you earlier also, the notes that we are writing here in the class, these are sufficient. Whichever you are copying down in your notebook, these are sufficient. So that's why I want you all to have all the small details also, which are not so very important. Like I'll tell you, right now only I'll tell you, some things are not very important in this lesson. Whichever are, I'll mention. So basically, two things you have to remember about bar magnet. First point is that they are artificial. They are not natural magnets. They are created by humans. Secondly, they are permanent. Once created, they last. That's it. These are sufficient points. All these points are extracted from your books. Now, properties. First point is the attractive property. Attractive property basically means north-north will repel each other, south-south will. These will repel each other. Only north and south will attract each other. So these are what I'm telling you. These are not so very important that you have to remember them. But since it's mentioned, so anything can be asked and you cannot question them and mark it as out of syllabus. All right. So very easy, you people can understand this very well. Directive property means, see, directive property means, suppose I have a bar magnet. This is the free end of a string and I have taken a bar magnet. Freely suspended bar magnet. As I'll leave it, after a while I'll notice that this bar magnet is properly aligned in north side south direction like this. This is also one property which we call as directive property. Along this direction, it will arrange itself. In the starting, it will be like this. You will tie it. It will be like this. After a while, this will look like this. Third point, magnetic monopoles do not exist. See, we talked about plus Q, which was existing like proton. Protons do exist independently. We talked about minus Q, negative charges, electrons, which are existing independently. You never see set of electron and proton always existing, or they are not depending upon any other elementary particle for their existence, right? So here magnetic monopoles do not exist, means it's not possible that you have taken a bar magnet, north, south, you have cut it into two parts. This part is north and this part is south. This is not possible. What will ultimately happen? If you have this part as north, this part as south, then automatically here south polarity will develop, and at this end north polarity will develop, because monopoles in magnets can never exist. North pole or south pole solely cannot exist. If this is existing, means south pole is already present over here. If this is existing, it means north pole is already present over here. Fourth point, last point, that magnetic induction means, see, if you take objects like iron ball, if I take an iron ball, I have taken an iron ball, and on one hand I have taken a bar magnet and I have rubbed this. So slowly I'll notice that once I have rubbed it for a long time, momentarily, this iron ball will also act like a magnet. If I stick it on a metallic wall or a metallic almirah, it will stick momentarily. After a certain time, it will again lose its magnetic property and it will become back as the iron ball. But this property of inducing magnetism momentarily, though, but inducing magnetism by a magnet, this property exists in bar magnet. That's why we are studying magnetic induction. It is inducing magnetism. And the substances which are getting induced, these are known as magnetic substances, like iron ball. Iron ball has the tendency. You keep on rubbing a piece of wood for a year with the help of bar magnet. Piece of wood will remain as it is because that is not a magnetic substance. Iron ball is a good example, which has the maximum chances of successful experiments done on magnetic induction. So these 4 points are the properties of bar magnet. These are pertaining to bar magnet. Some more theory portions are left. We'll discuss it. First, write down all these. Separate page from the new page, write it down. Not from where you have left resistance and conversion of galvanometer. Class, now apart from the properties that we are talking, terms relating to magnets we have to study. Now these terms are not particular for only for bar magnet. These means these terms are for bar magnet, but these are not as such property of it. These are terms that we'll be using further, so you should be aware. Like magnetic polarity. Magnetic polarity we have discussed also. South polarity and its direction also we discussed, how to remember clockwise. And north polarity, how to remember anti-clockwise. Fine. So north pole you have and south pole you have. Second, you have magnetic axis. Magnetic axis is basically a line that is joining north pole and south pole. So transversely it cuts the magnet like this. This is known as magnetic axis. Then magnetic equator is, see, first if you drop magnetic axis, this is magnetic axis, perpendicular to magnetic axis, this making an angle of 90 degree, this is known as equator. So line passing through the center of the magnet, this is longitudinally, that was transversely. Magnetic axis was transversely, this was longitudinally. And what is magnetic length? Magnetic length is basically separation between the north pole and south pole. Means entire length of the magnet. This is known as magnetic length. These are certain terms which you have to remember. This is very important, comparison between electrostatics and magnetostatics. Write down these terms. These are the terms relating to bar magnet. See class, now regarding the comparison of electrostatics and magnetic, why we are studying it as a comparison? Because you just have to convert it. You just have to convert it. The analogs, like we have the concept of electric charge, right? Plus Q, minus Q, these are the two types of electric charges which are existing. SI unit is coulomb. We are all aware of this. This was the first topic we studied. Magnetic charge basically means, see, there is no particular charge. When we say magnetic charge, this basically means magnetic strength. So magnetic strength is represented by plus M and minus M. Now, the way you have electric dipoles we have studied. Electric dipole moment was charge multiplied by their separation, right? If two charges are present, plus Q minus Q separated by a small separation. Identical charges with opposite sign. This forms a dipole. SI unit also we had, which was coulomb meter, right? So in magnetic dipole moment, here also M will be charge means magnetic strength, whatever is the strength of the magnet, separated by the separation. If plus M minus M, this is existing and their separation is L. All right. Here also you will write it as Tesla meters, SI unit. Then electric field we studied across axial line and equatorial line. This we have studied that if you extend the axis and you are taking a point, so electric field was, here you had calculated it as Kp 2 Kp by R cube, right? Which meant 2 P by 4 pi epsilon naught R cube. So here when you will construct the analog of it. So here also at an axis, if you're finding, see magnetic field will be, it will be 2 K M by R cube. But what is your K here? K is mu naught by 4 pi. So this is mu naught by 4 pi R cube. This is the formula in magnetic field for axial line. And you have equatorial point also, equatorial line. So equatorial line also we studied, plus Q minus Q. If we had, this was separation R, and if we are calculating at this point, so formula was minus Kp by R cube, right? Minus P by 4 pi epsilon naught R cube. So you'll convert each term. Here also if you have plus M, you have minus M. At this point, if you are calculating, so magnetic field will also be minus Km by R cube. Convert every analog. 1 over 4 pi epsilon naught. This becomes mu naught by 4 pi. P becomes M by R cube with minus M. Exact same formula. When we are talking about torque was P cross E. Here torque is M electric dipole moment, magnetic dipole moment. Electric field, magnetic field. Didn't we study this yesterday also? MB sine theta, right? Last is work done. See, work done, if a charge is there, plus Q minus Q. This is making angle theta 1. This has been shifted, making angle theta 2. So how do we write the work done equal to potential energy? In chapter 2 we did minus P dot E cos theta 2 minus cos theta 1. Here also, if one angle is theta 1, another angle is theta 2, work done will be, see, P will become M, E will become B, M dot B, cos theta 2 minus cos theta 1. If you just have solo potential energy, we used to write minus P dot E, which was equal to minus PE cos theta. Here also you will write minus M dot B, which is equal to minus MB cos theta. Like this. So this was a revision of all the formula which we did in electrostatics and its analog in magnetostatics. Question, I'll discuss it later. First, you make it in the form of table so you remember this. Write it down. SI unit for magnetic strength, we write it as Tesla only. Tesla. For this also, we write it as Tesla. Done. Fadil.
Yes, ma'am. Yes, ma'am.
And the last part, work done. All of you, all those who have completed, you can leave. Attempt your after class assessment. Tomorrow, no, on Saturday we'll meet now. Thank you so much, class.
Thank you.